Hey, Dr. Asatar Bear with video today on part two of utility theory and indifference curves. All right. Uh, so what we talked about in the previous video in part one, we talked about uh, these assumptions around what is human nature. Okay, we said human nature is to maximize utility subject to constraints. And this idea, combined with a couple of other assumptions, is known as the rationality assumption. Okay, so by saying individuals maximize utility subject to constraints, it's synonymous with saying we believe individuals are rational. We assume individuals are rational. And sometimes this assumption has been known as the Homo economicus assumption. Homo economicus, rational economic man. I know it's a bit sexist to say it that way, right? But this is anyway the part of the literature. Okay, so this is human nature, right? Now, to refine this concept a little bit, we make a couple of assumptions about preferences. Okay, like I mentioned, we assume that preferences are number one, complete. Number two, that they are transitive. Number three, that there's non-satiation. And number four, that the law of diminishing marginal utility exists. Okay, so and sometimes this assumption is called convexity. I've also heard it described as concavity. It depends on which way we're looking at it. Right. What we said is these assumptions together produce an indifference curve. Right. So where the quantity of good one, quantity of good two, where we get something that looks like this. Okay, so again, I'm gonna title this. This is an individual's indifference curve for these two goods. All right, good one, quantity of good one, and quantity of good two. Okay, an individual's indifference curve. It's always only relevant for one individual. Okay, so because everyone's preferences might be different, and microeconomic theory is fine with that. Okay, we're not saying everybody has to have the same preferences, not at all. All right. All we're saying that everyone has in common is that everyone does this. They maximize utility subject to constraint, and their preferences work in this manner. Right. That is what gives us an indifference curve. We can label the indifference curve one. Okay. I see the way I did that. I utility with a bar over it, one. Okay, and the reason for this is we assume, look, every point along this curve, the individual is indifferent between this point and this point and this point and this point, etc. Right? So if we were to choose 2 points along here, right, A and B, we'd say, well, the way this must be is that for this individual, they are indifferent between A and B. Okay, but here's the thing, right? If we say, okay, B is a certain combination of these two goods, all right, let's say this involves 7 of good 2 and 10 of good 1, all right, so the indifference curve, the rules of the indifference curves, okay, so here's what we've learned, all right, the indifference curve uh, always has a negative slope. Always has a negative slope. Okay? We can see that the slope is changing, right? It's steeper here than it is here, and less steep over here, right? But it's negative in all of these, at every point along it, it's negative. Okay, we can also infer from this, right? So again, let's compare this to point A. Point A, let's say, is like this. We've got 3 of good 2 and we've got 13. But the slope changes along the curve, right? And the reason that it changes is because of our last assumption here, all right? The law of diminishing marginal utility, the concavity assumption, okay? So this curve is concave with respect to the origin, okay? So 0. Concave with respect to the origin, meaning it's curved, not a straight line, all right? It's curved, and the slope is going to be changed along this thing, okay? And if it's curved in that manner, we're going to go from less steep here to more steep here, like I said, all right? So the slope changes, and we can describe the slope, right? The change in the vertical, that's Q2, over the change in the horizontal, Q1. We describe that as the MRS between these two goods, right? The marginal rate of substitution. And we said this is equal to negative mu1 over mu2, okay, like we did in the first video, for part 1. All right, MRS, the marginal rate of substitution, okay? And what this refers to, very important concept here, is this individual's willingness to give up good quantity of good 1, okay, to give up some of good 1 in order to then gain good 2, all right? So in other words, the marginal rate of substitution is a very, very important concept, right? That's telling you exactly how much the individual likes something, right? How much an individual likes something. That's much more precise than we're used to, right? So let's say that we find that the marginal rate of substitution is something like this, okay? Let's say that it's negative, negative 0.25. Okay, so the change in the rise over the run, right? If it's negative 0.25, what this is telling us is the individual is willing to give up 4 here if they can gain 1 over here, right? Because 1 over 4 is a negative is equal to 0.25, okay? So that's the relationship between loss and gain, all right? What the individual needs to receive in order to feel okay, right? Feel okay, what does that mean? That means indifference, right? We are assuming that along this curve, the utility is fixed, okay? That's the meaning of this right here, okay? So fixed or constant level of utility, right? Constant level of utility. Okay, so the slope is very, very important of this thing. That's the marginal rate of substitution. Now we can also infer from this, like, okay, so A and B are both along the same curve. The individual must be indifferent. But if we choose another point, okay, let's say point C over here. Notice that point C has more of both, right? So, like, it's A versus C, you've got the same amount of good 1, but you've got now more of good 2, okay? So, look, if the individual likes both of these goods, it must follow from that, right? Again, by the nature of what we assumed, okay? We assumed complete preferences, transitive, non-satiation, and the rest. It must be the case here that C is preferred to either A or B, right? It must be the case, right? That's the transitive property, okay? If C is preferred to A, the C also must be preferred to B because these two are indifferent. You're indifferent between the two, right? Now, if you prefer C over either of these points, well, that changes our situation, right? Okay, so we're not on the same indifference curve. We must be at a higher level, okay? So a higher level, that implies that we are on so higher level implies that we are on a higher and better indifference curve. We could call this one indifference curve 2, okay? So the logic of this is we have an infinite number of indifference curves here, okay? How do we know that? Well, we assumed, okay, non-satiation. it's always possible to get more utility. It's always possible to have something that you would prefer more, right? So if you prefer it more, okay, that must mean there's an indifference curve out here, which would be preferred, an indifference curve further out, etc., 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 going on forever in the positive direction. And the same thing as we get closer and closer to the origin, to zero, okay? Less utility, less of the two goods, okay? So there's an infinite number of indifference curves in this space here, all right? That is utility space, okay? As we go further this direction, the level of utility goes up. As we go further in this direction, the level of utility goes down. Now, we cannot say exactly how much it goes up or down, right? Because remember, the big problem that the indifference curves are designed to solve is we can't directly measure or observe even utility. We cannot measure or observe utility. So like I said, we don't know exactly what the number is, right? I said in the last video, this concept of the util, okay, the 1 unit of utility, that's not real, right? There's no util. You know, like if we're measuring light, oh, I don't know what light is. Show me what that is. Okay, here's light of a certain wavelength, right? We can measure that, we can observe that, okay? So this doesn't exist, right? That's a made-up word. And so the indifference curve is a way of trying to get around that, okay? Yeah, we can't observe utility, but we can observe the popcorn and the candy. We can infer from that if the person prefers one, that must mean that that's higher utility, okay? So sometimes in the literature, this is described as the difference between cardinal utility versus, as it's called, ordinal utility. Okay, so this one we don't have, right? Cardinal means that we can put a number on it, right? Like a number like 5 or 10 or whatever it is, right? The numbers are a cardinal system, okay? So where we can say like, oh, if we have 4, that's twice as much as 2, all right? So we're saying, look, that's not possible with utility. But what we can say is we can create an order, okay? So like if an individual, let's say B is preferred to A, which is preferred to C, well, this is an ordinal statement, right? B, then A, then C. That's ordinal utility. The individual prefers B to A to C, okay? So that we can do, right? And it turns out this is enough to establish the thing that we want to establish, all right? What we want to establish is that individuals maximize utility subject to the constraint, okay? That's the kind of end game here, right? What we started with, that assumption that we started with, all right? So the bottom line here is this whole space on this graph is utility space. There's an infinite number of these indifference curves out here, okay? They always have a negative slope, and they also cannot cross, all right? If they cross, it's a violation of our assumption, okay? It violates the transitivity, right? That's our second assumption. The number's not really that important, right? But it violates the transitivity assumption. All right, let me show you why. So here's our graph, okay, Q1, Q2, and let's imagine that we have these two curves on here like this, okay? This is indifference curve 1 and indifference curve 2. This causes a problem for us, right? Because we can very clearly see that, like, let's say that we choose a point, okay, like a point on the axis, like, you know, let's call this point 1 and point 2. Right, so we can see. Look at what's happening in these two situations, right? At point 1, you have the same amount of good 1, right? But you have more of good 2, okay? So we are assuming, look, if you have the same amount of something that you like, you don't have to give up anything, but you have more of this other thing that you also like, right? well, then you're going to prefer that, right? So, and because the we just said that, look, it's all along this curve has a constant level of utility. Okay, what's happening over here is that indifference curve 2 is going to be preferred to indifference curve 1, right? They'd rather be here than here, okay? But over here, the opposite is true, right? Indifference curve 1 would be preferred to indifference curve 2. So that is a contradiction, right? These both can't be true. And so that's why we say they can't cross without violating our assumption. If you see them crossing, that's an error, right? And the reason that I'm, going over this is because this is important for us to be able to understand this, right? The graphs have a meaning. They have an economic interpretation, and so for us to understand every part of it, then we understand the meaning more, right? Um, Indifference curves can't cross. Okay, this is part of a general topic which tells us the shape of the indifference curve reveals the individual's preference. Okay, reveals the individual's preference. So every individual may have different preferences, and that's going to express itself in a slightly different shape of the curve. Okay, we would have a different marginal rate of substitution based on that different shape. Okay, for two different individuals, right? Like we said before, for one individual, the marginal rate of substitution between these two goods was, let's say, negative 1/4, right? Meaning, for this individual to give up one of good 2, they would need to gain 4 of good 1. Okay, so that's a particular statement about their preferences, right? For another individual, let's say the marginal rate of substitution was negative 1/5, right? Why would it have a different marginal rate of substitution? Because it has a different slope, right? Why does it have a different slope? Because it has a slightly different shape. Okay, the shape of it reveals the individual's preference. Like for this other individual, okay, so let's say this is individual A, this is individual B. Okay, so for person B over here, they're saying, listen, if you're going to take one of my, popcorn away, or what did I say good 2 was? I said, you get candy, right? You're going to take one of my pieces of candy away. You're going to have to give me 5 pieces of popcorn for me to be indifferent between the two of them, okay? Versus this person is saying, for you to take away one of my pieces of candy, you're going to have to give me 4 pieces of popcorn. See how that's a difference? That's a measurable difference in their preferences. Now, that would be relative to a certain level, okay? That's not universal. It depends on how much, candy or popcorn or whatever that you started with, right? And you're taking away one. Well, is that your last piece of candy? Or is that your 100th piece of candy? Because remember, there's a law of diminishing marginal utility, right? Your 100th piece of candy is not giving you as much additional utility as your, first or second one or whatever, right? So the shape of the indifference curve reveals the individual's preferences. And I can show you that a little bit in a little more detail, okay? Like if we talk about certain special cases of the indifference curve, okay? So normally when we draw the indifference curve, we're going to be drawing it as a curve, okay? Like I showed you guys on the last graph, okay? A special case is there's something that is very special about one or more of these goods or the relationship, okay? And we can see that in terms of the shape of the curve, all right? Now, normally, we assume that the individual likes both things. They like both good 1 and good 2, okay? But if the individual dislikes one of the goods, all right? Let's say that they dislike good 1, all right? So having more of good 1 in that situation does not add anything to that individual's level of utility, right? So they dislike good 1. Then this would be what the indifference curve would look like. Okay, a special case, all right? So if they have, let's say, they have 2 of the good 2 that they actually like, right? And they are indifferent between having 2 of good 1 versus having, let's say, 10 of good 1, right? These points would be indifferent, A and B, right? They'd be indifferent along that curve, okay? So, well, what would make them happier? Well, what would make them happier is if they had more of the good that they actually liked, okay? So this curve would be preferred, right? We would, in this special case, we would, again, we have an infinite number of indifference curves in this space, but the indifference curves are flat, okay, because the individual dislikes one of the goods. Okay, this is not normally what we assume, right? Normally, we assume that they like both goods, and that gives us a nice curved shape, okay? But this is just to show you, okay, if an individual happened to dislike one of the goods, it would produce either a flat one if they dislike good 1, or a vertical one if they dislike good 2. All right. All right. Let's do another special case. Let's say that the goods, good 1 and good 2. Let's say that these goods were what's called perfect complements. Perfect complements. So what does that mean? If it's truly perfect, it means that you have to have good 1 to even use good 2, right? Perfect complements means they absolutely go together, right? You gotta have both of them, otherwise it's absolutely no good to you. Now, nothing is truly perfect in this world, but this is the concept, right? If we had perfect complements, we would have an indifference curve with a very special shape that would look like this, okay? Because you need, let's say, 1 of each of them for that to be any good to you, right? Like if you have 1 and you have 5 of the other one, well, those aren't any good to you, right? That's the same as having 1 and 1, okay? But if you had more, then you would prefer that, okay? So same idea, right? There's an infinite number of indifference curves. They're going in a positive direction as we go that way, right, away from the origin. There's an infinite number of these curves, but they have this special shape because they have this certain relationship, okay? They're perfect complements. Okay, so special cases, they're just to illustrate, right, this general point, which is the shape of the indifference curve has everything to do with the individual's preferences that we're talking about, okay? It's a map of the person's preferences. Okay, so our next point here is we've got to explore the notion of constraints, right? What we've said is as we go further and further away, right, these curves we get greater and greater levels of utility, right? The individual would prefer that. So, what we haven't gotten into is, well, where's the maximum, right? There's no end to this. We're trying to say, how does a person maximize utility? And to do that, we've got to bring in the notion of constraints, okay? So in terms of constraints, when we think about like what are the things that limit your ability to get good 1 and good 2, right? That's what constraints are. And there's 3 basic things that limit your ability to get good 1 and good 2, okay? And these are your income. Remember, we're using the term Y to stand for that, okay? Your income and the prices of these 2 goods, okay? The price of good 1, P1. The price of good 2, P2. That's what limits your ability to consume these goods, okay? It is the okay, those 3 terms, Y, P1, and P2. All right, now we can also show, all right, that look, there's certain maximum quantities of good 1. Okay, so the maximum quantity of good 1 is going to be found by taking your income, Y, and dividing by the price of good 1. Okay, and the same thing for the maximum quantity of good 2. You're going to take your income and divide by P2. Let's put some numbers into this, and we will see, what we're talking about here. Okay, so let's say that your income is equal to $20. The price of good 1 is equal to $1, and the price of good 2 is equal to $2. All right. So we can see from this, right, the maximum quantity. It's pretty simple. Okay, we're going to take $20, divide by $1. We get 20. Okay, that's the maximum quantity that that person can attain of good 1. All right, 20 over 2, or 10 for good 2. Okay, so we can put this on our graph. Quantity of good 1, quantity of good 2, 10, 20, 10, 20. Draw this so it comes out real nice. Dr. Bear, how come you haven't been using a ruler for any of your other stuff? Well, all right. Anyway, so we go from our two maximum points, okay? So y over P1 and y over P2, right? We connect in between because, there's all these in-between points that are also possible, right? And this is a representation of our constraints, okay? It is called the budget line. All right, so the budget line is different from the indifference curve, right? The indifference curve was solely based on the individual's preferences, okay? So the indifference curve is very subjective. The budget line is not subjective, right? It doesn't have anything to do with what you like or dislike. All it tells you is what's possible, right? Given these three variables, okay? Your income, price of good 1, and price of good 2. Now, we are saying, too, that, from the perspective of the individual, the price of good 1 and price of good 2 they're fixed, right? They're not something that the individual can choose, because we are saying that they come out of a competitive market, right? Where there's so many buyers that no one buyer has any power over the price. No one seller has any power over the price. Each person in the marketplace regards these prices as fixed. All right. The income, you have some choices you can make around that, which we'll get to later when we discuss labor markets and capital markets. All right. So the budget line tells us all the points, meaning, what I mean by points, the combinations of good 1 and good 2 that are possible, that can be attained given our givens, right? Y, P1, and P2, given our constraints. Okay, all of the points that are possible. Now, if these things change, right, if we get a change in any of the things that we said, right, a change in income, let's say. Okay, let's say this individual has more income than before, right? Let's say this individual has, they get a raise. Well, this is going to shift the budget line out in a positive direction. Okay, so right, change in income shifts the budget line. Okay, change in income shifts the budget line. If it's an increase in income, it shifts it out. If it's a decrease, it shifts it in. The slope doesn't change. Okay, the slope of the budget line doesn't change, right? Because if you have a little bit or a lot more income, that doesn't really affect the relationship between these goods. Okay, the relationship between these goods doesn't change. Their relative prices one to the other doesn't change. Okay, so a change in the price of good 1 or the price of good 2, that is going to shift the budget line as well. But unless they both change in exactly the same relative amount, it will also change the slope. Okay, so it'll do two things. It'll shift it, and it could also change the slope. All right, so in order to understand this, we have to look at the formula for the budget line. Okay, the budget line has a general formula. Okay, general formula for the budget line. And that is just due to its structure. Okay, so remember, we're using Q1 as like our X variable, horizontal axis. We're using Q2 as our Y variable. All right, so we want to put this into an equation for a line. All right, so the general formula of the budget line, we're going to say Q2, and then we need the maximum over here, right? Because this is like our y-intercept, okay? So our maximum would be y over P2, all right? Then we look at, okay, so y over P2 minus P1 over P2 times Q1. All right, so remember, in terms of this, right, Q1 represents our X variable. Q2 represents our Y variable, all right? Big Y over P2, this represents our intercept term, all right? And negative P1 over P2 represents our slope, all right? So the format for a line that you're familiar with, usually when you see this, it's in a XY format, right? Like you might see something like this. Y equals 4 minus 2x, okay? So this is just using different variables because remember, it's economics class, right? Economics, the variables have an economic meaning, right? That Q1 is the quantity of good 1, Q2 is the quantity of good 2, etc., okay? So we're not putting it in terms of X and Y, even though that's more familiar to you perhaps. We're doing it in this format because we want to keep that economic meaning foremost in our minds, right? So we go from the general formula to the specific formula. We plug in our terms, okay? So we're going to plug in, we're going to say, in this case, right, the formula for the budget line, Q2, remember, we got our maximum y over P2. We already figured out what that is 10, okay? Then we've got the prices of good 1 and prices of good 2, 1 over 2, and then we're just going to put in Q1, right? Because remember, we have like X and Y, okay? Because those are our variables, okay? 10, and these are our constants, right? The intercept stays the same and the slope stays the same along a straight line. Okay, so the specific formula of the budget line in this case is Q2 equals 10 minus 1 half Q1. All right, and this tells us what's possible for the individual, right? Now, remember, we have said the individual wants to maximize utility. So they want to go up until, and good 1 and good 2, this is giving the individual utility. So they want to go all the way up until the line, right? They want to go as far as they can, okay? Let's bring all this together now. Here's our situation now, right? Again, we've laid our thing out. We've got good 1, good 2. Okay, we've got our budget line, which was in here, right? Going from its maximum position on this axis, y over P1, to its maximum position on this axis, y over P2. Okay, so our budget line, and what I did was I added for an individual their indifference curves. Okay, so here's indifference curve 1, indifference curve 2, and indifference curve 3. Now keep in mind there's an infinite number in this space, right? How many curves can fit in a space? Well, a lot, right? Infinite number. So I just did 3 just so we can see what's going on here, okay? And I'm gonna just add a couple of points here, okay? Point A, point B, and point C. All right, so here's what we know, right? Here's what we can infer from all this logically based on our assumptions and all the stuff that we've done thus far, right? We can infer a certain relationship between A and C, right? So point A and C, from the perspective of this individual, they must be indifferent, right? How do we know that? Well, they're along the same indifference curve, okay? Along the same indifference curve. That's what that means, right? That is the logic that we have established, okay? Now, here's what we also know, right? We also know that any point along U3 would be preferred to any point along U2, which would be preferred to any point along U1. All right. How do we know that? Well, because we showed, right, if we draw a line, well, you have the same amount of this good, but you have more, that would be better, right? So we know that's the case, right? Relative to these three indifference curves, U3 would be the best, right? Anywhere along that, okay? Because any point is indifferent, and it's better than any point along here, okay? But here's the thing we also know, right? If we consider these, let me add another point, okay? We've got A, B, and C, and then let me add another point, D, okay? So again, point D is the one that's along the indifference curve 3, right? So that would be preferred to any point along U2, that would be B, right? And that is going to be preferred to, A, which it's indifferent to C, right? So this is what we know, right? I just translated into symbolic language, right? Now here's what we're trying to get to, okay? We're trying to say, how does the individual maximize utility subject to the constraints, which are Y, P1, and P2, okay? See, I'm using more of this symbolic language, okay? Maximize utility, that's a concept that comes from calculus, right? Maximization or optimization. Subject to, ST stands for subject to, and the constraints, and I've just listed out what they are, okay? Y, comma, P1, comma, P2, okay? 3 constraints, all right? The constraints give us the budget line, okay? So if we add the constraints, what this tells us is points A, B, and C, well, these points are all possible, right? Because they're along the indifference curve. That tells us what's possible, okay? Now we could also choose some point inside the curve, right? Like we could choose some point E. That's also possible, but that doesn't go up to our full budget line, right? That would mean that we're not spending all of our income. We are assuming for the moment that the individual spends their whole income because remember they're trying to maximize utility. Okay, they get utility from the goods. They spend their entire income. All right. Later on, we'll modify this assumption a little bit to explain like why might a person save something, but that's later. All right. So points A, B, and C are all possible. They can be attained by the individual. Okay. But point D is not. Okay, that's not possible. Right? The individual does not have the money given what the prices are. They don't have the money to get to D. Okay, so A, B, and C, all of these are possible. Now, what we want to explain the individual's behavior. We want to show like, well, what are they going to do? Which one are they going to choose? Okay, so they are going to choose the point which it gives them the best indifference curve, right? The highest indifference curve. Okay, so the individual is going to choose the point along the budget line. You choose the point along the budget line that results in the highest possible indifference curve. Okay, so that's on the highest indifference curve that they can possibly get to. All right, and that is point B. Okay, so how do we know it's point B, right? Well, how do we know it's not point A? We know that B is better than both points A and C. How do we know that it's the best possible curve? Okay, so, well, here's the thing about point B, okay? Point B is something special, okay? We've got a curve which is concave toward this line, right? So if we've got a curve that's concave toward the line, that means there will be one unique mathematical point, which is called the point of tangency, okay? So this concept, it's called tangent, right? That means it just touches in one point, okay? One mathematical point. And the unique thing about tangency as a concept, okay, if you've studied calculus, you know this, right? The qualities of this, it means that the slopes are equal, right? the slope of the indifference curve becomes equal at that point to the slope of the budget line. Okay, so, and this is a very special thing, right? So the slopes become equal. Let's just indicate this up here. Okay, so the slope of the budget line, remember what that is? That's negative P1 over P2. That becomes equal to the slope of the indifference curve. Remember, we defined that as the marginal rate of substitution, and that's equal to negative mu1 over mu2. Okay, so slope of budget line equal to slope of indifference curve. Now that's the only place that that's true, right? So we can show mathematically, we can prove mathematically that this point, the point which involves these two things, right, at which the slope of the budget line is exactly equal to the slope of the indifference curve, it must follow that that is the highest possible indifference curve that you can get. And what we mean by that is, well, we have just shown the individual has maximized utility subject to the constraints. Okay, we can prove the individual maximizes utility without using the concept of utility. Well, we're using the concept, right? But without having to measure it, without having to say, oh, the utility is 50 utils now. We don't have to do that, okay? All we have to do is say, well, all we know is that it's the highest, okay? The slopes are equal. All right, I'm going to do a little exercise. I'll show you. This marker represents the slope of the the indifference curve, right? So along this, we can see the slope of the indifference curve changes, right? It's different here than it is over here, right? The green marker represents the slope of the budget line, right? That's always the same. So if we go over here to point A, right, the green marker, that's that, right? But at point A, see how these slopes are not equal? Okay, the markers are not at the same angle relative to each other. And the same thing at point C, right? This one is like this, and this curve is like this, right? I'm proving it to you with the markers, okay? Versus at the point of tangency, the slopes are exactly equal, all right? So, I know not the most rigorous proof. Advanced microeconomic theory goes into more mathematical detail to develop a rigorous proof of this exact proposition, right? So, but here's the thing, right? We just let's take it on faith, if you would. If you're really interested, take more microeconomics courses, and they will give you this whole proof. But what we're saying is this negative P1 over P2 equals mu1 over mu2. This is called the utility maximization condition. Okay, the utility maximizing condition, because it's the only place where this is true, right? At point A, the slopes are not equal, like I said, right? So negative P1 over P2 would not be equal to negative mu1 over mu2. It's not equal anywhere along the indifference curve, anywhere along the budget line, except for at that one point, at point B. Okay, point B is the only point which satisfies that condition. So this is the great workaround of indifference curves. It allows us to show that the individual has maximized utility subject to the constraints without using utils, without having to measure utility. All we need is ordinal utility, right? All we need is the notion of preference. We need it to be true, all these assumptions, right? That people have complete preferences, their preferences are transitive, and the rest, right? That all needs to hold true. But assuming that does hold true, then we can show, right? This must be our point of consumer optimization or utility maximization. Same thing, okay? So maximization, optimization, these mean exactly the same thing. My last point here is we can use our indifference curve analysis to derive the demand curve. Okay, so before, part one, I said that indifference curves, utility theory is like the foundation of the demand. Well, there's two things that drive demand. Um, there's the constraints, okay, the income and the prices, and the second thing is the individual's preference. All right, so let's show how these are related. Okay, let's here's our indifference space. Okay, quantity of good 1, quantity of good 2, and directly below that we will draw another graph which same horizontal axis Q1, but now we're putting the price on here. Okay, so if we change the price of good 1, keep constant the price of good 2, we're going to change the slope of the budget line. Let me show you how that will work. All right, let's say that the price of good 1 was initially like $3, right? And then it goes to $2, and then it goes to $1, right? So what is that going to do? Well, that is going to shift out this budget line, and it's also going to change the slope. Okay, it's not going to change anything up here, right? Because remember, we're assuming that two things are staying constant. Okay, the price of good 2 and the person's income as well, right? So income over P2, these things are staying constant. So this doesn't change, all right? But as we lower the price, change the price on this, we're going to get a different maximum figure over here, all right? What this is also going to do is it's going to change the consumer's behavior, right? We're saying, look, here's what the individual is going to do in every case, right? They're always going to maximize utility subject to our constraints, right? The prices and the income. That's not going to change. But what does it mean in terms of how much do they buy of one thing versus the other? How much do they buy of what it means in terms of how much they buy of good 1? Well, that does change. Okay, so here's how it would change. All right, so I got 3 indifference curves on here. Indifference curve 1, indifference curve 2, indifference curve 3. They're choosing based on this. Okay, where is the slope of the budget line, negative P1 over P2, equal to the marginal rate of substitution? Okay, negative MU1 over MU2. Now that might be a different point. If we change the price, we're going to get a different point. Okay, so but here's what's happening, right? Let's just say, okay, the optimal quantity for this individual, as the price is lowered of good 1, see how the person's behavior changes, right? The optimal quantity for that individual. Okay, let's call it Q1 star. Okay, so at the initial, we've got two things. Okay, Q1 star and Q2 star. Okay, so choose these quantities, Q1 star and Q2 star, based on, well, where is this the case, right? Where, given the prices and the income, where is this equal? Okay, so initially that's here, right, at point A, but then it changes, right, because we've changed the price, and then it changes again to point C. Okay, so what we can do is we can make inferences based on that. Okay, so we can go from this individual's, let's say that this Q1 star initially was like 3, okay, and then after the price changes, we get to point B, and now we're at 7, right? And then once the price changes again, then we're at 11, right? So we got 3 different optimal points based on what is the price. Okay. Now, if we put price on this axis, $1, $2, $3, okay, and then connect these, so when the price is equal to $1, we are at point C, right? When the price is equal to $2, we are at point B. When the price is equal to $3, we are at point A, okay? And if we connect these dots, we get a, so here's what we've done, okay? We have gone from the individual's indifference curve, okay? We've gone from the individual's indifference curve. What's this based on? It's based on their preferences, okay? They are going to make a choice based on what is their preferences. That's where the red curve, the indifference curve, meets the green line, right? Because the preferences are not the end of the story, right? There's also constraints. There's an objective world out there. You don't get to just have as much of goods as you want, right? You're limited. There's constraints. Okay, so where does that meet the constraints? And what we get out of that is called the individual's demand curve. Okay, if we change the price, how does this individual behave based on that? And we can see the individual demand curve is downward sloping, right? So even though like Marshall proceeds in a different fashion, okay, Marshall doesn't use all of this stuff, right? Exactly. What he does, Marshall assumes, okay, there's a law of demand, right? He is starting from the position of analyzing the whole market. So where microeconomics went is they looked at, okay, how can we take it from the perspective of each individual, right? So this individual, this is their individual demand curve, right? But of course, we're interested in the whole thing, not just one individual. But here's how we do it, okay? We're going to add up all of these individual demand curves, okay? Add up all the individual demand, and that will give us the market demand curve. All right, so the point of this analysis is we are showing that the demand curve has a rigorous logical foundation. All right, so microeconomics is a very, very logical theory. It's a lot like math. It uses a lot of math because it's designed to show that it's valid by means of a proof. Okay, so earlier this is called rationalism, right? To prove something is true means we know it is true because every step in the process has come from what we assumed before. All right, so the point of indifference curves is to work around the problem, right? We're saying maximize utility, and maximize refers to a number. I mean, that's hard to avoid, right, in the final analysis. But Edgeworth, Pareto, and others who developed this did their best to try to get around that problem. All right, that's my lecture for today. Thank you very much.